All right. Good morning, afternoon, good evening, whenever you may be, live from the Brenner Bunker. It's eighth grade science here at ACE Academy. Once again, we have some interesting things going over in our energy resource unit. Just remember to like the video, say hi in the comment section. And remember, if you have any questions or anything, please give me a call, 704-363-9034. We'll talk to you at any point during normal day. 10 to 4 is normal office hours. You can contact me outside of that. Just remember, I may or may not take your call after those hours or before those hours. But guess what? For the most part, I do, as long as you're not calling in the middle of the night. Anyway, so energy resources, I can discuss the depletion of non-renewable resources. Remember, depletion means something is running out. So over here, we see a mine shaft that is basically closed, and it's already, you see it's starting to cave in. Whatever, it's danger, bad air, means you can't breathe in air. Over here, we see an oil well that has seen better days and is obviously not working anymore. So that oil well has been depleted, and they're no longer pumping oil out of it. So non-renewable resources by definition are limited in supply. At the time a mine is opened or a well is drilled, the scientists from the companies doing the work already have a good idea of how much coal or gas or oil they're going to get out of the ground. It's not guesswork or divining to get the right place to dig or drill. Careful scientific surveys using state-of-the-art equipment that shows them where to start their exploration. For every first gallon of oil, every first shovelful of coal, every first cubic foot of natural gas, they know there will be a last one for that site as well. Depletion of a single site is when a mine or well no longer has recoverable material. That's the standard definition of depletion is run out. Now, in the business of resource recovery, there is an economic cost of getting oil, gas, or coal out of the ground. You got to pay the guys to dig coal. You got to pay, you get electricity to run the pumps on the oil well. You got to pay, for water and fracking sand for your fracking wells. I mean, it costs money to get things out, to mine or pump oil or gas. So when the mines are first open, the cost is usually pretty low. It's usually pretty easy to pump out oil or gas out of a newly, open well. The miners don't have to go very far on the shaft of the pit to get the coal. And as the process continues, it's harder to pump the oil and gas out. The miners have to lift the coal from deeper and deeper into the earth. At a certain point, the price the company gets for the barrel of oil or ton of coal doesn't pay for the cost of extracting it from the earth. Remember, when you pull this stuff out, you're selling it on an open market. You're competing with other people who mine coal and drill for oil and gas. So there is a marketplace, and so the price of a barrel of oil or a ton of coal is set by what people are willing to pay at the time for that material. So if it's too expensive to get stuff out of the mine or pump it out of the well, the mine or the well is economically depleted. It's not the fact that it's empty of stuff, it's just it costs too much to get the stuff that is left in there out. There's still valuable material there, it just costs too much to get it out of the ground. Most companies at this point will shut down production at the site and probably mothball their operations there. Depending on how much of the resource they estimate is still available, they're going to make a decision on whether to remain in mothballs, basically leave the equipment there to the point where they can come back and open, start back up again if the price goes up, or to cap the well or the mine. If there's a significant amount of resource still available, they'll usually just remain in mothball status with the idea that at some point the price of this stuff's going to go up. We'll show back up, open the mine back up, or open the well back up, pumping, mining, or getting oil and coal out of the ground. But if there's not that much resource left at the site, they will cap the well or mine and perform reclamation on the site to return it to its natural state. So, but in either case, they did not really run out of the resource. It simply became cost prohibitive to recover. Depletion of non-renewable energy resources is more of an economic state than an actual state of run out of. We all know that when we empty the last of the Cheerios from the box, we have depleted our supply of Cheerios. There's no more in the house. This is absolute depletion. Physically, no more exist. Resource depletion is deceptive in that we can never get all the resources out of a mine or well. Sometimes it's a technology thing. Most of the times it's a economics thing. Some will always remain that is cost prohibitive at the current point to get out. This is where the economics of energy production play a very important role in determining resource reserves. At one time in 2008, the price of oil, a barrel of oil, was $160 a barrel. This was an extreme high price just prior to the 2008 recession. At $160 a barrel, many oil wells that were expensive to operate were running. They still made money for the operators. The recession hit and the oil price dropped. And it's gone down, it's gone back up since 2008, that's 12 years ago. So right now, the price of oil is $30 a barrel. A barrel is about 42 gallons of oil. Last month, the price was $18 a barrel. $18 a barrel, there is not many oil wells, especially in the United States, that can produce oil and sell it at $18 a barrel and make a profit. Many oil producers in the US are shutting down their wells because it costs too much to get their oil out of the ground. And you can only store so much, to perhaps sell at a later point. I'm just going to put it in these tanks over here. And when the price goes back up, I'll empty my tanks and sell it. Well, there's only so many tanks. Once you fill all those up, it's like, all right, what do I keep doing? Producing oil. Again, you can't really sell it for as much as it's costing to get it out of the ground right now. So, yeah, you tend to shut down the production. So there's plenty of oil in the ground for the foreseeable future, but it depends on the price of the oil as to whether it's economically viable to get it out of the ground. Our view on non-renewable resources and supply and demand is also changing as technology advances. So, and you got to think of it this way, because there's the whole, do we have it, and then there's the whole, what is using it and at what rate. So aircraft engines, and again, about 2 to 3% of demand over the entire planet is aviation. Aircraft engines have become about 45% more efficient since 1968. So not only does the engine become more efficient, but the airplane becomes more efficient as the technology allows it to have better designs, better wings, pierce the air better. So you can transport more people with the same gallon of jet fuel as you could before. Automobiles have become more efficient at the same time, going from like 13 miles per gallon to about 22 miles per gallon for the entire fleet of 260 million registered vehicles in the United States. Only Americans' preoccupation with SUVs has kept this number down in the low 20s. Your current mid-sized sedan, such as a Chevy Malibu or a Toyota Camry, gets about 32 miles per gallon. So if we didn't love the SUV, the Tahoe and the Suburban and the Explorer and the Excursion so much, that national average would be significantly higher, because the sedans that most people would have at that point instead of SUVs get 32 miles per gallon. So more and more cars are becoming hybrids, which means you've got a gas motor in there and an electric motor and a battery to supply, support electricity. And so when you're just puttering around in traffic or pulling away from lights, they just use the electricity from the battery that is there to get you going. And then as once your speed kicks up, or your battery life drops off, the gas motor kicks in and helps you out and recharges the battery. Those kind of cars get about 50 miles per gallon. Now, your straight electric vehicle is seen by many as the ultimate in environmental consciousness. Your Tesla, your Leaf. In reality, until our nation's electrical production incorporates vastly more renewable energy production, the electric vehicle simply changes the emission source from the tailpipe of the car to the smokestack at the power plant. So add in the massive environmental cost of batteries and electric cars, and they really right now don't add up to be the green epitome that a lot of people see them as. So again, you're just, when you see a Tesla ride by, it's like, hey, look, a coal-powered car. Again, we haven't had coal-powered vehicles since steam engines were running around back in the 30s and 40s. So anyway, so that's always a funny joke with me and the people that I know that have electric cars. It's like, oh, that's such a nice coal-powered vehicle. And they just grumble and groan because they bought it thinking they're going to be green, but they just didn't realize that here in North Carolina, still about almost 40% of our electricity comes from coal. So, and the other big chunk of it comes from petroleum and natural gas. So, so still, that is a fossil fuel powered vehicle. You're just transferring where the smoke goes in the atmosphere from the tailpipe to the power plant smokestack. Anyway, it's a running joke with me and some of them. They don't like it that much. Supply technology is changing as well. We've long known the U.S. has massive formations of oil shale. We simply did not know how to get the oil out of these structures. Then in the mid-'80s, oil well engineers started trying new ideas as technology advanced and allowed them to drill horizontally. So most, again, you think of an oil well, they drill down, it hits puddle oil, and then they suck it out of the ground, right? Well, horizontal drilling allows you to go down and then kind of curve this thing and go sideways. Whereas, the layer may have been this thick, and so you had just a little bit of space between the top and the bottom to drill into. But this thing is miles and miles and miles and miles and miles wide, but it's only that thick. So they drill in horizontally, and they can just drill, suck all the oil out, drill a bit more, suck all the oil out, drill a bit more, suck all the oil out. So the horizontal drilling really advanced oil production technology from individual wells. Then you add in hydraulic fracturing. So in the mid 80s, well engineers started trying new ideas with hydraulic fracturing and horizontal well drilling. And then and that really kind of changed how we get things here in the United States. But hydraulic fracturing, or fracking, as everybody's heard about it, is not something that's been new. Hydraulic fracturing has been around since the Civil War. A Union Army lieutenant colonel created it after when he was during a charge up to the Marye's Heights during the Battle of Fredericksburg in 1862. Under fire from dug-in Confederate troops up on the hill. They were firing down on him with cannon and rifle, and he was watching the explosive cannon shells come down. And when they exploded out, when they're just in the air, when they hit something on the ground, they kind of blew up, and you could see what would happen. And these explosive shells would hit the water, and they would explode underneath the water. And he actually kind of went, hey, wait a minute, that was definitively different what happened when that thing blew up underwater than when it blew up on land. And you got to think about this. This is a remarkable observation when you stop and realize that he was running up a hill with those cannon shells being fired at him when he was making these observations. So, when truly great minds have inspiration, it strikes at the most interesting of times sometimes. So he created the fracking industry in 1865. He's awarded a patent for his explosive torpedo and a superincumbent fluid dampening. There's one of those words that you just kind of go, what in the world does that mean? Superincumbent. I have no idea. I know what fluid is. Fluid's water. Dampening means to hold something down, like tamp down, tampening. Hold it down, keep the pressure in a certain area. Superincumbent, haven't a clue. But he would put explosives down the oil well and filled with water on top. The water concentrated the concussion forces in the area of the explosion and created a much greater oil flow than any other process known at that time. Made him a very, very rich man. Fast forward to the 80s, and new men of vision were using these new horizontal drilling techniques to drill horizontally into formations they previously couldn't really access. And then they started using hydraulic fracturing, which is hydraulic meaning water, pressure fracturing, which basically breaks it apart. Fracturing means tearing something apart. But in 2007, the price of oil went up, like I said, to $160 at the beginning of 2008. So when the pressure, when that oil price went up, all these oil companies said, hey, wait a minute, now it's worth it to us to go ahead and try out this new technology on a larger scale. And guess what? It worked like gangbusters. So 2007, the price of oil started climbing. U.S. oil companies started investing in horizontal drilling in the oil shales and using hydraulic water pressure fracturing, breaking apart to allow oil recovery from materials previously thought pretty much unrecoverable. And you can see here in the United States, we have a ton of places that has these oil shales in them. So it is Marcellus here in the eastern U.S. I mean, you hear the Devonian, the Bakken up here, Eagle Fields down here. Huge, huge oil boom from 2008 onward, basically putting the United States into the driver's seat when it comes to energy production. So the new use of old technology has allowed the U.S. to become the #1 producer of natural gas in the world. It is third in oil production and 10th in proven reserves. World supply of oil at this point, with new technology and everything, is nowhere close to running out, with over 100-year supply at current production rates. Over 100 years. And look how much technology has advanced. I mean, this is 2020. In 1920, let's see, airplanes were made of cloth. Basically, there weren't really roads between places. There were roads in the town you lived in. But if you wanted to get to the next town over, you had to jump on a train or ride your horse. The roads between places were very, very limited. It was, you didn't drive to the next town. You either rode your horse or you got on a train. Most people even didn't even have cars in 1920. It was still, we were just coming out of World War I. You know, we were still a predominantly agrarian society, you know, mostly farmers. Um, Things were still very spread out. And so that was 1920. Again, like I said, you know, airplanes were fabric, propeller powered fabric things that carried a couple people here and there. They were not anywhere close. You didn't ride an airplane to get places. You rode an airplane. They carried the mail in airplanes. That's about it. And if you know if you were a daredevil, you would actually try to travel one because they were still very, very unreliable and likely to not get you where you needed to go, and likely to kill you in the event of weather or anything else, because they had no way of navigating anyway besides sight. Um, that was, you know, like I said, the 1920s. So if you want to go somewhere, you had to ride a train. You know, cars were few and far between. Most people still used either shoe leather or a horse to get around. You know, so now we have aircraft travel that we can get pretty much travel the planet in about 20 hours. You get from any place to any place. That's what led to the spread of this disease so much, is because we travel everywhere all the time. And you know, we're about to send private people into space. Think about that. 100 years ago, airplanes were scary. Fast forward to now, we're about to send private people to take private rides into space. Just like, oh yeah, I'm gonna go orbit the Earth a couple times. Oh, cool. Hey, Johnny, next year we're gonna have your birthday party on the moon. That's not too far away, guys. So, so you know, in 100 years, I mean, again, if we have a 100-year supply, and think about what technology is going to be like in 100 years. I mean, probably can't really imagine what things are going to be like. So it's going to be definitely going to be different. And so, with alternative energy resources becoming more and more mainstream and conserving, you know, become more and more practical, the truly game-changing technology changes occurring regularly, the likelihood of depleting the world's fossil fuel sources goes down every year. Coming of commercial fusion power sometime in the next 30 years. Fusion is a type of nuclear power which produces no harmful radioactive material as its waste. Basically, it just produces water. The demand for fossil fuels, the supply of electric power will basically be near zero. With demand for the product, you know, remove fossil fuels, will have at that point a near infinite reserve life. As much as we like cars and the freedom they allow, we're not allowed, you know, we're not likely to give them up. But as better technology gets better, more efficient, the electric car will become more and more the norm. Again, reducing the need for fossil fuels. Again, this simply shifts the emissions rather than curtailing them, but as power supplies become more and more renewable and nuclear efficient and fusion based, it will result in lower demand of fossil fuels for personal transportation. So again, everything we're doing is basically decreasing the need for fossil fuels at a time when where our technology is allowing us to get more fossil fuels out of the earth than we ever thought were possible even a few years ago. So in the end, the likelihood of fossil fuel depletion is very low. But depletion of individual sources of fossil fuels is probable. So I mean, you'll hear, wow, it's fine right now, or this well was tapped out and ran dry. But that happens, has always happened. Every place, you know, every individual, you know, supply is limited. But as far as the world is concerned, we've got more oil than pretty much we can use at this point, given the other alternative energy sources coming online. All right, so we've reached the end of this. A couple more days of energy support sources. Then we'll have a small end of unit test for this because we're going to have like 8 or 9 days of instruction in it. And I'm not giving you a unit test the day before school's over. So Monday or Tuesday, you'll have a unit test, which will probably add 20 questions for this unit on Mastery Connect. And then it'll be the end of active instruction for the year. Remember to like the video. Remember to say hey in the comment section, and we'll catch you guys